Get set, go. Okay, today we take a new formula. So yesterday you learned about a lot of different trigonometric identities. We'll see if you remember any of them, okay? Secant squared minus 1, tangent squared. Nice job. 1 over 1 over cosine is the same as secant. Sine squared plus cosine squared. 1 minus cosine squared. Sine squared. See, you're looking at the sheet. You're making all these associations and memorizing. Good job. Good for you. Ishka's entirely confused. No, she remembers some of it. Of course you do. We missed you yesterday. Okay. You watched it yesterday? Okay, so you're good to go. I want to be clear that some of the problems that you have on your worksheet from yesterday, I would expect that 90% at least of the students within the class would need help on at least 2 or more of those problems. So if you got through all the problems with absolutely no help, I would say that you are one of the very, very, very rare people. Okay? So I expect lots of questions. If I'm not getting them, I know that people are definitely sitting in confusion. Here we go to sum and difference formulas for sine. We have new formulas to learn today. Sine of an angle A plus an angle B. This is what your inner temptation is. If you were to see sine of 60 degrees plus 45 degrees, you would want to say that that's the sine of 60 degrees plus the sine of 45 degrees. Your intuition says, well, I'm going to distribute the sine as though it was multiplication. And that's not multiplication at all. And this is 100% incorrect. If you do it on a test, I will get angry and start stabbing your test with my pen. So how do we make Mr. Gens happy? We write the correct formula. You actually take the sine of angle A and you multiply it by the cosine of angle B. How we get there? Then we will add on to that the cosine of angle A multiplied by the sine of angle B. If it was subtraction, then we would use subtraction down here. What do you think? Okay, we don't know what to do with it yet. We'll show you what to do with it in a second here. Cosine is a little bit different. Cosine of angle A plus angle B. It's going to be the cosine of angle A times the cosine of angle B. Cosines stay together. Instead of plus, so it switches to minus the sine of angle A times the sine of angle B. So if it was plus up here, then it's minus down here. So if it's minus up here, then it's plus down there. So this might be the first time you've seen a minus plus sign. It means do the opposite of what it was above. See that? Let's check out 1A and 1B. Sine of 23 times cosine of 67 plus cosine of 23 times sine of 67. The fact is that I don't know what the sine of 23 is, and I don't know what the sine of 67 is. But I can figure this out, its exact value, pretty quickly. You see, this looks like a formula I have right up here, doesn't it? This looks like the sine of some angle A times the cosine of some angle B plus the cosine of angle A times the sine of angle B. Well, didn't we learn that that's the sine of angle A plus B? So in this problem, what is A? 23. What is B? 67. What's 23 plus 67? 90. Get the sine of 90 degrees. Can we determine the exact value of sine of 90 degrees? Make the circle of life. Got this point right here at 90. We got 0, 1. Sam says, I know exactly what the sine of 90 degrees is. It's the y value. It is 1. How's letter B different? Okay, fractions. Let's say instead of fractions, let's say radians. Would you say this is a radian measurement for the angle? Yeah. So, and this fits the cosine formula, doesn't it? We have cosine of angle A times the cosine of angle B plus the sine of angle A times the sine of angle B. So what? So I'm just replacing the 2 pi over 3 with A, and I'm going to replace the 5 pi over 12 with B. So we can see that, does this fit the sine formula or the cosine formula? It fits the cosine formula. And is it cosine of A plus B, or is it cosine of A minus B? A minus B, it switches sign for cosine. Well, what is A in this problem? 2 pi over 3 minus 5 pi over 12. 2 pi over 3 and 5 pi over 12. I want to subtract those. What do you have to find? What's the common denominator? 12. So that would be the cosine of 8 pi over 12 minus 5 pi over 12. What's 8 pi over 12 minus 5 pi over 12? 3 pi over 12. What's 3 pi over 12 simplified? Pi over 4. So I have the cosine of pi over 4. Pi over 4 is how many degrees? 45 degrees. I want to try to find the exact value. I create the circle of life, 45-degree angle. What is the terminal point? Root of 2 over 2, root of 2 over 2. Is cosine the x value or the y value? It's the x value. So I get the root of 2 over 2. That's the exact value. What do you think? The other type of example that you'd be given is actually like this. The sine of 15 degrees. Now, if you notice in our examples up above, we made a 45, 45, 90, and we were able to find the terminal points, right? If we made a 30, 60, 90, we could find those terminal points too, or a 60, 30, 90, or just a 90-degree triangle. But we didn't talk at all about using 15-degree angles, did we? And that's just it. You can't make a 15-degree triangle and all of a sudden find the missing sides. It doesn't work like that. So we have to do something else. Can you think of two angles that come from special right triangles that either add to 15 or subtract to 15? 60 minus 45. You could choose 45 minus 30. You could choose 135 minus 20. You'd choose 150 minus 135. You got lots of options, okay? But they have to come from triangles who you can find those special angles for. So, well, let's expand that so we can find the exact value of sine of 15. How do I expand this? I get the sine of what? 60 times cosine of 45, plus or minus cosine of 60 sine of 45. I got two different angles going on. I got a 60-degree angle, I got a 45-degree angle. We already learned that 45-degree angle is root of 2 over 2, root of 2 over 2, right? And we did that up there. But for 60 degrees, I should make another circle of life here. I got a 60-degree angle. Does anybody know what that terminal point is? This is 1. This would be a half. Root of 3 over 2. So we've got 1/2 and root of 3 over 2. I told you a long time ago when we were finding these exact values of sine and cosine that you would have to do that for the rest of trigonometry and for calculus, and I'm not lying. I mean, these continue to come back up all the time. We need to know these. So sine of 60, is that going to be the x value or the y value? So I got the root of 3 over 2 times cosine of 45, root of 2 over 2, minus cosine of 60, 1/2, root of 2 over 2. What's the root of 3 times the root of 2? Over 2 times 2 is 4, minus root of 2 over 4. Hey, look at that. They got common denominators, don't they? So you get the root of 6 minus the root of 2 all over 4. How can I check my answer? Sine of 15 degrees. 8.2588. Well, I'm going to take parentheses, the square root of 6 minus the square root of 2. I'm going to divide that by 4, and hopefully I get the same thing. Hey, I do. Now, if you tried that, if you wrote down 0.2588 on your test, then I'm going to make a lot of red marks and start stabbing your test. So don't do that. See how I check the answer? Piece of cake, upside down. What's different about letter B? Cosine and radians. Let's get rid of the radians. Do you remember how to convert from degrees to radians or radians to degrees? Yep. So I get 7 pi over 12 times 180 over pi. They cancel. 180 divided by 12 is 15. 15 times 7 is 105. Get the cosine of 105 degrees. What I want you to do now is walk through the same process. You're going to come up with an answer that is similar to the square root of 6 minus square root of 2 over 4, but it's not going to be the same. It's going to be similar, but it's not going to be the same. See if you can carry out this the rest of the way. Go. Okay, let's check to see where you're at. What you should have here is the cosine of, I will use 60 plus 45 because I saw that that's what most people chose. Again, you could choose other workings, but everybody should then set up cosine of 60 times the cosine of 45 minus the sine of 60 times the sine of 45. Everybody good with that? So we already set up the 60/40s over here, didn't we? 60/45, we set that up here, didn't we? So the cosine of 60 was 1/2. Cosine of 45 was the root of 2 over 2. The sine of 60 was the root of 3 over 2. And the sine of 45 is the root of 2 over 2. So you can see that you end up with the root of 2 minus the root of 6 all over 4. Similar to what we just had, isn't it? What's different about it? It's switched. What is that going to do to the value? It's going to make it negative because the square root of 2 is smaller than the square root of 6, isn't it? So our result is negative. Let's see if that makes sense. It's 105 degrees. Which quadrant is 105? Second quadrant. Cosine, positive or negative, second quadrant. Negative. Yeah. See? And all trig is related. All trig is connected. Back and forth. Good. All right. 2 more examples. Sum and difference formula for tangent. Oh, by the way, folks, if you don't have the sheet out, take the sheet out right now. You want this one right here, okay? So like today, this is where we're at. We're at the sum and difference formulas. So you get this sheet of notes on the test, right? Like I give you the formulas. You don't have to memorize them. But a lot of people, I shouldn't say a lot, I've had a couple people throughout the years, they get to the test, they end up with, 6 out of 44 on their test. They come back to me after they're done crying. They say, Mr. Gantz, I got a 6 out of 44. And I said, well, it didn't seem to me like you knew where to get the formulas from. They said, no, I didn't. I said, well, didn't you use that sheet? They're like, well, yeah, I had the sheet, but I had no idea where to find the formulas on it. And I know that sounds stupid, but here's the deal. What do you think they were always using when they were doing their homework to find the formulas? Their notes. Do you get your notes on the test? No. So you guys want to make sure that you are looking at this and not your notes as you're working through your assignment. Does that make sense? I mean, it didn't occur to me right away, but, so I'm trying to let you know. Second thing is that sometimes people, they actually highlight. They make this one blue and that one red or whatever so that they stand out. So like, oh, yeah, I remember going to the blue box for this one. I remember going to the red box for that one. Red box is like a movie thing, but not a movie thing. You know what I mean? Like, this is a lot more fun than a movie. Great movie, by the way, Braveheart. Never seen Braveheart? Gotta watch Braveheart. Okay, all right. There we go. You were raised on Braveheart? Wow. Nudity and violence. That's oh, sorry, YouTube. That's we should probably censor this. Okay. A lot of violence. Sum and difference for tangent. Tangent's different. Suppose you have the tangent of A plus B. That works out to be the tangent of A plus the tangent of B. Is that awesome? That's the numerator. The denominator is 1 minus the tangent of A times the tangent of B. Tan, tan. Yeah, the plus symbols kind of get lost in the T's, don't they? Yeah. So if this switches to minus here, then it switches to minus there and switches to plus down there. I could show you the proof, but it would take us, yeah, times. What's that? So if it's plus here, then it's plus here, and it's minus here. If it's minus here, then it's minus here and plus there. Same on the top, opposite on the bottom. Ready to roll? I believe in you, folks. Find the exact value of tangent of 19 pi over 12. What do I need to do? Switch from radians to degrees. 19 pi over 12 times 180 over pi. Pi's cancel. 180 divided by 12 is 15. 15 times 19, who knows? 15 times 20 is 300. 285, very good. It's okay. So I got the tangent 285 degrees. So what I need to do is I now need to write this as two angles that add to 285. So if you check out our list right here, there are two angles right there that add to 285. Yeah, 240 and 45, that works out well. 225 and 60, that works out well too. Yeah, we'll use the 240 and the 45. That's what was brought up first. We got the tangent of 240 plus 45. So we're going to need two triangles going here, right? Well, what's the 45, 45, 91? Root 2 over 2 and root of 2 over 2. That's what I meant. So when you have the root of 2 over 2 and the root of 2 over 2, how do you determine tangent? You do what? Sine over cosine or y over x, and we divide them, you get 1. Hey, isn't that nice? So I know that the tangent of 45, when I get to tangent of 45, then I'm going to get 1. Because the terminal point for a 45-degree triangle is the root of 2 over 2, root of 2 over 2. Then to get tangent, you take the y value divided by the x value. We good back there? I'm getting a smile and a hand. All right. So now I got to do 240. 240 degrees is going to make what type of angle? 30, 60, 90. It's that kind of triangle, but it's the 60-degree angle right there, right? Because it's 60 degrees past 180 for the 240. Yeah, very good. So it's negative 1/2 and negative root of 3 over 2. So I divide those two, don't I? Negative divided by negative is a positive. So I get the root of 3 over 2 divided by 1/2. Multiply by 2 over 1, and I get root of 3. Okay, YouTube Nation, some of them are identifying that these worked out really nice to be 1 and square root of 3. Some people are becoming a little high maintenance, and they're saying, well, it could have worked out a lot better if it came out to be like 1 and 0, or how about just 0 and 0, or 1 and 1. And so, or just no soul. That's their favorite solution, because then work ends. But so anyway, let's persevere. Okay, so tangent 240 plus 45. How do you write this out? 240 plus tangent 45 over what do I replace with the tangent 240? The denominator, 1 minus root of 3 times 1, which is just going to be 1 minus root of 3. They're married. Can I? Yeah. Oh, gosh. Yes, YouTube Nation, they actually wanted to do this. And the sad thing is that they wanted to come up with 1, and they just totally disregarded the negative altogether. So even the incorrect math was incorrect. So it was a sad day for us. Excellent. Thank you. I hear some great mathematics speaking forward. People say multiply by the conjugate. When in doubt, when you don't know how to do the math, do the Spanish. All right, let's look at what happens first here. I get the square root of 3 times 1, and 1 times the square root of 3. What's that going to give me? 2 roots of 3. And then, what's the root of 3 times the root of 3? And what's 1 times 1? So that's going to add to 4. So that's the numerator. Let's check out the denominator. 1 times 1, 1. And then the middles go away, right? Like that's the whole idea about multiplying by the conjugate. The middle goes away. So you get negative root of 3 times the root of 3. Negative 3. 1 minus 3. Negative 2. Do those divide? Yeah, I take the 2 out. Negative root of 3 minus 2. Yeah, a little trickier. 285, which quadrant? Very good, fourth quadrant. Fourth quadrant is tangent positive or negative. It's negative. So we should come up with that negative result. Let's just try it here. I get negative root of 3 minus 2, and I get negative 3.73. If I try the tangent of 285, I get same thing. Great. Great. Root of 3 times the root of 3. 1 times 1. Add them together. Yeah. Root of 3 times 1, root of 3. 1 times the root of 3, root of 3. Add them together, 2 roots of 3. Because you're going to FOIL that guy. It is a lot of work, but fortunately we're extremely intelligent and we can do it. Okay, Marty's getting bored. He says he already knew how to do the lesson. He wants a proof. Marty will step it up for you, okay? I say proof. Oh. All right, sorry, YouTube. We just had to have a kind of a little bit of a therapy session. Every time the word proof comes up, there's just this, we call it PTSD, post-traumatic stress of geometry syndrome. And it's a sad thing. But we're going to survive. Here's the wonderful thing about proofs. You know the answer. I have to get from the left side to the right side. So what should the result be? The cotangent of u. That's what I should get. So here's what I'm going to start with. I start with the right side. The tangent of pi over 2 minus u is equal to, and now I have to put something into transition. I have to make my argument. Now, I'm going to give you a hint here. Tangent is the same as something divided by something. Right. So I'll have sine of the angle, or pi over 2 minus u, divided by cosine of pi over 2 minus u. Hey, it's interesting that they're giving us this type of proof in this section where it looks like you have subtraction of angles. Do we know how to do difference of angles with sine and cosine? Yeah, we just did it on the front page, right? So the top will expand to what? Sine of pi over 2 minus u. How does the top expand? Sine of pi over 2 times cosine of u minus cosine of pi over 2. Good. Excellent, excellent, excellent work. Divided by cosine of pi over 2, cosine of u, plus okay, now is the moment where you want to reserve your groans and your yawns and your complaining because it's going to get really, really, really awesome. Okay. All right. So, all right. Once again, the okay. Yeah. YouTube. It's incredible. You know, they brought back. Let's just cancel everything off. Somebody, I'm not going to name names, but Noah said we're gonna get 1. Maddie then inserted -1, and they're all disregarding the fact that we know the answer doesn't come out to be 1 or -1. It comes out to be what? Cotangent. So you're completely wrong altogether. If at this point you wrote cotangent, I would give you 1.5 points out of 3. Yep. Okay. Now, let me show you, and it's this is where you guys, this is literally your brain's gonna grow right now in the next 2 minutes. Watch, it's so beautiful. Pi over 2, how many degrees? 90. And so what's that coordinate? So you guys just talked earlier about how it's so awesome when we get zeros and ones, right? And you guys do recognize that in order to get to cotangent, some things are going to have to cancel, right? Well, watch what happens. Instead of sine of pi over 2, what do we put in its place? We put 1. Instead of cosine of pi over 2, what do we put in its place? 0. Instead of cosine of pi over 2, what do we put in its place? Instead of sine of pi over 2, what do we put in its place? So look at what you get. You get 1 times, which is Why does the rest of it just go away? Because it's times 0. So we've got that on the top. What about the bottom? Sine of u. Now, I gotta give props to a professor of mine.